In this lesson, we are going to discuss the existence of the limit. So, if the limit of the function f of x, okay, we are going to say that this function approaches L when x tends to a. If the function from the left, f of a, from the right, a positive, is the same as f of a from the left, f of a negative. If each one of them equals, let's say, L, so the function exists, or the limit exists. The limit exists, and f of x approaches L when x tends to a. Let's take an example about that. Here I have the function f of x is x squared plus 2 when x less than or equal to -2, and x to x plus 3 if x is greater than -2. So we can draw this number here, and here's -2. And we write this function here on the right, which is 2x plus 3 on the right, because x greater than -2, and on the left, x less than or equal to -2, we are going to write here x squared plus 2. And we are going to find f of -2, x approaches -2, from the right. So we're going to find the limit of this function here, 2x plus 3, when x approaches -2. So it will be 2 times -2 plus 3, it will be -1. And f of -2 from the left. So the limit of this function here, it's x squared plus 2, when x tends to -2. That is going to be -2 to the power of 2 plus 2, which is 4 plus 2, it's 6. So as you see here, the limit of the function from the right is not the same the limit of the function from the left, because f of -2 from the right is not like f of -2 from the left. So limit of f of x when x tends to -2 doesn't exist. Okay, let's go to the next thing. Here, for example, I have f of x as defined as x plus 2 to the power of 2 minus 4 over x multiplied by x plus x squared plus x, if x greater than or equal to 0. So we have here 0 here, and we have a function if x greater than 0. So right here on the right, we write here x plus 2 to the power of 2 minus 4 over x squared plus x. And we write on the left 1 minus cosine squared 2x over x squared. To find the limit of f of x when x approaches 0, we are going to find f of 0 from the right. F of 0 from the right. That means you are going to find the limit of f of x when x approaches 0 from the right. So you are going to find the limit of x plus 2 to the power of 2 minus 4 over x to the power of 2 plus x when x tends to 0. So here, we can expand this expression. Is going to be x squared plus 4x plus 4 minus 4. All divided by x squared plus x. We can take x as a factor. So it's x multiplied by x plus 1. Cancel 4 and -4. So take x as a factor. It will be x plus 4 at the top, and x multiplied by x plus 1. Cancel x and x. Then put instead of x0 is going to be 4. And you will find from the limit of the function from the left, it's going to be limit of 1 minus cosine squared 2x over x squared when x approaches to 0 from the left, okay? So 1 minus cosine squared 2x, it's a sine squared 2x over x squared, okay? Then we can write it as sine 2x over x, all raised to the power of 2 when x tends to 0, okay? So that is going to be 2 over 1, all raised to the power of 2, which is 4. As you see here, f of 0 from the right is the same as f of 0 from the left. So the limit of the function, limit of f of x, because they are the same, when x tends to 0 equals 4. That's it. Now let's go to continuity. And before studying continuity, I want to show you this graph here. What is the f of 1 from the right? F of 1 from the right, the limit of the function from the right. Go up here from the right more than 1 by a little bit, it's 2. And f of 1 from the left equals, go to from 1 here, less than 1 here, up, you will hit 2. Because f of 1 from the right is the same as f of 1 from the left. So the function has a limit. The limit of the function when x tends to 1, it's 2. What about continuity of this function? The limit of the function here is when x approaches 1 is 2. But this function is not continuous. Why this function is not continuous? Because f of 1, okay, doesn't or is undefined. If we moved here from 1, what is the value of 1? There is no value for 1. So f of 1 is undefined. Okay? So this function is not continuous. Okay? So we have 3 conditions to say that the function is continuous. What are the 3 conditions? The 3 conditions, number 1, the function is defined. The function is defined. Okay, at x equals a. At x equals a. Number 2, the limit of the function when x tends to a exists. When x tends to a exists. Okay. And the third condition, we have 3 conditions, 1, 2, 3. The third condition, f of a is the same as limit of f of x when x tends to a. Let's look at this graph here. Discuss continuity here at x equals 3. So f of 3 equals 2, and f of 3 from the right, you will go up here, you will hit the curve at 2, and f of 3 from the left, you will go up here just less than 3 by a little bit here, you will hit f of 3 from the left equals to, as you see here, the limit of the function when x tends to 2 equals, when x tends to 3 equals 2, and f of 3 equals 2, because the limit equals the value of the function, so we say that this function is continuous at x equals 3. Discuss the continuity of the function here. To discuss the continuity, find f of 4 firstly. So f of 4 here, you will find it's 2 times 4 to the power of 2 minus 7 times 4 minus 4 over x minus 4. We have a problem here. If we put 4 at the denominator, you will get 0. So this function is undefined, f of 4, undefined. So because f of 4 is undefined, so f is discontinuous. The function f is discontinuous. okay? And I want to redefine the function to become continuous. How can we redefine the function to become continuous? So you will find the limit of the function. The limit of the function if x tends to 4. So it's 2x squared minus 7x minus 4 over x minus 4. X tends to 4, not equal to 4. You will factorize it. So when factorizing it, you will get 2x plus 1 multiplied by x minus 4 over x minus 4. Cancel them out. And put instead of x here, it's 2x plus 1. So 2 times 4 plus 1 is going to be 9. So the limit of the function f of x, if x tends to 4 equals 9. So to make the function continuous at x equals 4, it is necessary to make f of 4 must be equal to the limit. F of 4 must be equal to the limit of f of x when x tends to 4, which is 9. So we are going to redefine it and write the function f of x is going to be 2x squared minus 7x minus 4 divided by x minus 4. And x not equal to 4. It's not equal to 4. And right here 9 if x equals 4. I redefined it to make it continuous because the limit here, if x tends to 4, not equal to 4, the limit here is 9. So I wrote that the value of the function f of x equals 9 exactly if x equals 4. That's it. Redefine the function f of x equals 4 cosine x over pi minus 2x to become continuous at x equals pi over 2. First of all, the function is undefined. The function is undefined at x equals pi over 2. Okay, to make the function continuous at x equals pi over 2, it is necessary that f of pi over 2 must be equal to the limit of f of x when x tends to pi over 2. So we are going to find the limit of 4 cosine x over pi minus 2x. You know that sine pi over 2 minus x is the same as cosine x. So we are going to write it as 4 and write limit. And instead of cosine x, we are going to write sine pi over 2 minus x, okay, at the top. Then you are going to take 2 as a factor here. So that is going to be pi over 2 minus x at the bottom here. Now we can apply the law we have learned. It's 4 multiplied by this limit here when x tends to pi over 2. So it will be 1 over 2. Okay, so 4 times 1 over 2 equals 2. So we are going to redefine the function as f of x equals what? Equals 4 cosine x over pi minus 2x, okay, when x not equal to, when x is not equal to pi over 2. And you write the value of the limit here, which is 2 when x equals what? Pi over 2. That's it. This lesson depends on all calculus we have studied. So try to study well all rules we have studied in calculus. See you in the coming episodes. Goodbye.